In this problem, we're being asked to evaluate the indefinite integrals. Now, when we look at these integrals, we have to ask ourselves, is this a standard integral? Is it power rule? If it's neither of those, or we can do a rearrangement, if we can't do any of those, we need to think of substitution. So in this case, there's no formula for this. This is not power rule. There's no rearrangements. So we're going to try substitution. And the key to substitution is we need to choose an inside function whose derivative will be accounted for on the outside. So in this case, there's really not much choice. The only inside function really we can use is this one here. We could possibly use a whole square root, but it makes more sense to at least try just the inside there. So I'm going to let my u be 5 sine x plus 1. That makes my du, the derivative, equal to 5 cosine x. And I'm going to times the dx. And notice that there it is. There's my cosine dx. I'm going to solve for my cosine dx by just dividing both sides by 5. And now I can do my substitution. I can replace my cosine x dx with du over 5, and I'm going to replace the other part of that integral. So it's going to look like this. I have a square root. Inside the square root, I have my u. I'm going to replace that with u. The cosine x dx, I'm going to replace that with a du over 5. So I'm going to put the 1 over 5 on this side. This becomes a really simple integral to do. We can use power rule for this. So we end up with 1 over 5. Power negative 1/2 becomes u to the power plus 1 is positive 1/2. We're going to divide by 1/2. So I can put here, I'm going to multiply by the reciprocal instead of dividing by 1/2. And then don't forget the plus c. Cleaning up those coefficients, I get 2 over 5 for the fraction part, and then square root u plus c. Okay, just moving that up here. I'm going to replace that u, because remember that u really was 5 sine x plus 1. So my antiderivative function is going to be 2 over 5 square root the 5x, so 5 sine x plus 1, and then on the outside we have our plus c. So there is our indefinite integral. For b, the same thing. It's not a power rule because there's an embedded tan in here. It doesn't look like this is a standard integral. There could be an algebraic rearrangement. The only thing that we might be able to do is do this. We could maybe try the tan breaking into sine and cos, so we get sine squared over cos squared. So then we end up with sine squared over cos to the power of 4. But again, this one, there's really nothing we can do with that. Okay? So we have to kind of look a little bit deeper here, and it's important to recognize in this one here, we can express it like this. Tan x all squared, and the cosine x, this cosine squared in the denominator actually can be expressed as a times by secant squared x. Now, why would I want to do that? Is because if I let u equal the inside function tan x, okay, so that on the inside of that power is a tan, the derivative of that inside function du is going to generate the secant squared x that I need. In fact, notice that there it is. There is my du showing up right in that function. So the derivative of the inside accounts for the outside, so I can write it like this. U squared, and I'm going to replace that secant squared dx with a times du. Well, this just becomes integral in terms of u. I can use power rule. I end up with u cubed over 3 plus c, and then all I need to do is replace that u with the inside function tan. Okay, so that inside is going to be replaced by the u that I chose, which was tan x all cubed. Okay, so this is my indefinite integral. We could clean this up and rewrite this as tan cubed like this. Okay, and again, if you want to test this, we can test this by differentiating. In fact, let's do a check here. I'm going to do a check by differentiating the power 3. Remember, after this is chain rule, I have to do the outside first, so I get 3 over 3. That accounts for that divide by 3. I reduce the power by 1. Okay, and then I have to apply chain rule. The inside is tan, so the derivative is secant squared. Yeah, that's going to show up as tan squared x over the secant squared just becomes cos squared in the denominator. So there it is. That shows me that I did end up with the correct antiderivative function.